The term micron is everywhere in modern metrology. Manufacturers face tolerance demands in the microns. MSPs and OEMs promise accuracies within a few microns, and it's even become the namesake of some computer and medical device companies. Micron is a very popular buzzword, but how long have we been using the micron as a guideline? What is a micron? And just how small is it? Micron is actually short for micrometer, which is the official unit of measurement. Micron was accepted as shorthand for micrometer in 1879 along with its symbol. The name and symbol, however, were revoked by the International System of Units in 1967. While the symbol has been abandoned in favor of the micrometer symbol, micron itself has remained in use colloquially and officially in various industries since. In America, this is primarily to avoid confusion between micrometer and micrometer, the measuring instrument in written language. Put simply, a micron is 1/1,000,000th of a meter, or 0.0000001 meters. It can also be expressed as 1,000th of a millimeter, or 39 millionths of an inch. There are plenty of size comparisons that can be found online, like this chart that shows how a micron is smaller than even bacteria, which are typically about 5 microns. As you can see, microns are well below the limit of visibility, which means that some of the tolerances being measured in today's manufacturing are too small to be seen by the human eye. Like the chart showed, even this hair is 50 to 100 times the size of a micron. Meaning for measurements that call for 25 micron accuracy, we are literally splitting hairs. But these comparisons can be found with a simple Google search. Is there another way we can look at the scale of a micron? We came to USA Hockey Arena, home of the US men's and women's Olympic ice hockey teams, to show a different scale comparison for the micron, from an unexpected source. A regulation hockey puck is 3 inches or 75 millimeters wide. This is more than 75,000 times larger than a micron, which helps illustrate the crunch that manufacturers are under. Their goal is to be accurate to within a handful of points, more than 75,000 times smaller than, thank you, this puck. But what if we reverse that scale? What if we increase the size of a micron 76,923 times until it was the size of this hockey puck? What would some of our size comparisons look like then? That bacteria that was 5 microns earlier, at 15 inches, it's now the size of a large pizza. You gonna eat all that? And that human hair I was holding earlier, at 25 feet wide, it is now almost the width of this face-off circle. To go 1 inch at this scale, you would have to travel 1.2 miles down the road. And 1 meter? That will now span 47 miles. But what if we took something much larger, like this 30-foot face-off circle? At 433 miles, it's now a face-off circle that can cover most of the Midwestern United States. And this hockey rink that's 197 feet long, at our hockey puck-sized micron scale, it is 2,870 miles wide, which is more than 700 miles wider than the diameter of the moon. And the blades that would skate on that rink are the product of high-precision manufacturing. We're here with Jeff Azalin of Blade Tech, just outside Toronto, Ontario, where they're manufacturing skate blades.
Yeah, we manufacture our skate blades to 115 thousandths of an inch. We have a tolerance of plus or minus 1 thou. Although this tolerance might seem different from other industries like maybe aerospace or automotive where they're looking at things in the microns, this tolerance of ours of 115 thou is important and works well for the skating world.
And the top sides of these blades are manufactured to equally challenging standards, as they're designed to be changed rapidly in-game.
That's correct. So when the blade is going to go up and into the holder, if we're out of tolerance on the high side, or the blade is too thick or too large, it's going to be a problem getting it up and in, and take a longer time to get it out, and it could jam. On the other side, if the blade is too thin or under tolerance on the low side, it'll go into the holder easily, but there might be too much room in there, and some lateral side slop and the blade could rattle around. And that's not good either, because then our players are losing performance, efficiency, and power, and they're not getting that reliability that they need. So sticking to this tolerance Making sure that we manufacture to our CAD models and being consistent is what we need to do to provide our players the best performance.
Excellent. Thank you.
Thank you.
As Jeff mentioned, other industries require much tighter tolerances, however, from parts as large as airplane wings or as small as medical implant devices. The dimensions and features of these parts must all be manufactured accurately, within a few microns. And just as importantly, the inspection processes on these parts must be accurate to those same demands, to ensure that the models and machines producing the parts are accurate and repeatable across multiple runs of the same part. Laser trackers, laser line scanners, and coordinate measuring machines, or CMMs, are just some of the methods for high precision inspection in modern manufacturing, and you can find videos discussing these methods on this channel.